Today is 27th of March, 2025. Today, we will talk about linear regression. First, linear regression is a function, homoscedasticity and normality, which follows normal distribution, and no collinearity, which means data should be not correlated. And then with linear regression, you will do some significance test, which is from beta 1 to beta p, is everything is just zero, which is whatever input is, it's just zero, which means input is not significantly impacted. We use statistics with F statistics, which is MSR over MSE, which we can calculate it by following table, which is you can find SSR first and SSE later, which is yi hat minus y bar square, and another thing is yi minus y hat n square, and divided by degree of freedom itself. In linear regression case, it will be 2, which means n minus 2, mean is 1, and p is another 1. You can ask why F statistics, because each of the numerator and denominator follows chi-square distribution, which is chi-square distribution is x1 square plus xp squared. Each of the x1 or x square follows normal distribution, then it follows chi-square distribution. In this case, it would be follow chi-square F distribution because we have assumption which is normality. For someone who forgot statistics, there's 2 ways we can use to test. One thing is critical value, another thing is p-value and significance level. Critical value is that you can define here, which is G sub alpha over 2, then usually we use G equals to 1.96. This is critical value. When we compare it, you found F value, you compute F value and compare with this one. If computed value is bigger than critical value, then we will accept H1 and reject null hypothesis. Or we can found P value, which is probability based on significance level. Let's say significance level is alpha equals to 0.01. And if you found P value, and if P value is smaller than alpha, it means when P value gets smaller and smaller, it will get H value, which is more extreme. Then we will also, in that case, reject it. So we will now see the multiple input variable cases right now. In multiple input variable case situation, we can explain it as linear algebra, X matrix, B matrix, and epsilon matrix, which will follow normal distribution. In this case, y equals to xb plus epsilon. In this case, this epsilon is population's epsilon, and for sample space, samples, we can say y minus xb hat equals to e, which is samples of epsilon. Then we can represent it as y minus yn hat, and we need to differentiate it, so we scale it. Then we can also y minus yn scale is able to, we can represent it as e dot product e, or vector e's length. Oh, wait a minute, was it scale or vector e's length? I forgot. I'm confusing right now. Confused. Then we can represent it as vector transpose multiplied by vector format, y minus xb hat equals to y minus xb. Then we can, what we need to do is minimize it. How can we minimize? We can differentiate it. If we differentiate it, then it will be minus 2x transpose y minus xb hat. Then it will become a b hat equals to xt x minus 1 xt y. And we can also then we can write it as y hat equals x b hat. This is hy matrix. We can represent it as xy. Hy, which is h is defined by x transpose x minus 1, x transpose. And we can also represent covariance of E as sigma square 1 minus H matrix. This was y minus yn, y hat I square. And another thing is we can yi hat minus y bar hat square, and we can, if we sum up these together, then we can find out these values. So based on the calculation, wait a minute, b hat equals to b1 hat equals to x minus x bar, y minus y bar sum up, and sigma x minus xi x bar here, and b0 hat is y hat y bar minus b1 x bar. This is also a bit complicated right now. B hat, and there's b1 hat, b0 hat. Right, it's not much. And lastly, for critical value and p-value, we can represent it with CD. There's method CDF and PPF, which is CDF is if you give the critical value, it will return probability. And for this, if you give probability, it will return critical value. There's something I'm confusing right now. I will figure it out and give it next time. Thank you.